We're going to start another example. This is example 3.2. This is another example for payback period. So we have an alternative, the first cost. I'm going to give you the information. You have it in your slide. So this is 1,050. The annual operating cost is $70 plus 5K. K in this case is equal 1, 2, and net income is 200 plus 50K. Now, they ask you a couple of questions. Part A, they're asking you if the minimum attractive rate of return is 5%, also the useful life of the equipment is 7 years, is this an acceptable project? There's one more information. They assume the salvage value. For this one, it's going to be called $500 anytime you sell this one. That's made assumption here. They want to know if this is a good investment for part A with the rate of return of 5%. We're going to continue with the example 13.2. Now, what we have to do here is, first, I'm sorry, we didn't do the cash flow diagram, right? No, I have to do it. I'm sorry, let's start over. I thought we have the cash flow in previous part. We didn't do it, right?
I think you just do it in part 2.
Yeah, okay, part 2. Okay. So we're going to continue example 13.2 here. So what you have to do is we have to come up with a cash flow diagram for this alternative. So the initial cost is 150. Then your income first year is 250, and it's going to increase by $50 every year. If this is on year 1, year 2, the next one is going to be 300. The next one is going to be 350, and continue up to year n prime. Also the cost. The cost for the first year is going to be $75, and it's going to increase by $50. So the next one is going to be $80. The next one is going to be 85, and so forth. Now, at the end of year n prime, you have the salvage value of 600. So that's basically the cash flow diagram represented in this example, this alternative. Now, we are trying to come up with the payback period equation. You're spending $1,050 at time 0. You're going to set equal to the present worth of the future cost and income at time 0. Since I have 250 here and 75, I'm going to subtract these two numbers. So that's basically, you have a uniform income of 250 and uniform cost of $75. The net difference is going to be 250 minus 75. That's going to be uniform. We're going to multiply this one by P given A. Again, we are doing part A here. And the interest rate for part A is 5%. And we're going to do this one for n prime. So that's the present worth of the difference between the annual cost and annual income. Now we have the gradient. The gradient, this one increased by $50 for the income. For the cost is $5. So that's the gradient. You're going to multiply this one by P given G, 5%, and n prime. So that's basically my payback period equation. So obviously this equation is difficult to solve because if you substitute for P given A and P given G, it's going to be a huge equation and it's not going to be linear. It's very difficult to solve. So what we're going to do, we're going to guess. I'm going to start with n prime equal 2 here. Also, I'm going to take this 1050 to the other side of the equation. So it's going to be 250 minus 75 times p given a, 5% and 2 period, plus 50 minus 5 times p given g, 5% and 2 period. And there's one more thing I left here, just the present worth of the salvage value, 600 p given f, 5% and n prime. Again, I just forgot to add this one to my payback period equation. So I'm going to add that part to it. So it's going to be 600 p given f, 5% and 2 period. Now, minus 1050. If I do so, you're going to get the net difference is going to be negative $139.64. So obviously, 2 years is not my answer because I didn't get this equation to go to 0. So what do you have to do? I have to go next guess. I have tried to find another n value, which I will get at least a positive number, then I can interpolate. We're going to continue with example 13.2. We use n prime equal 2, we get a negative number. We'll try to give n prime a different number to see what we're going to get. So I'm going to give in the next guess 3 period. So I'm going to substitute in the equation for payback period and to see what number I'm going to get. So we're going to have 1050, that's the first cost, plus 250 minus 75 times p given 8, 5% and 3 period, plus the salvage value 600 p given f, 5% and 3 period. This time you're going to get a positive number. It's going to get positive $63.37. So obviously my n prime, it's somewhere between 2 and 3 years, because for 2 years I get negative $139.64. For 3 years I get positive $63.37. So obviously the n prime is somewhere between 2 and 3 years. I'm not going to do the interpolation because you have done many times. So the n prime, if you do your linear interpolation, n prime is going to be equal to 2.7 years. Remember, that's your payback period. The useful life of the equipment is 7 years. So obviously this is much less than 7 years. So what does it mean here? This is a good project. It means you're going to recover within 2.7 years, much less than 7 years. So it means this is a good project. Now we're going to continue with example 13.2. In part A, we use the minimum attractive rate of return of 5%. And we decided this alternative is an acceptable alternative. Now in part B, we're going to do the same thing. Only the minimum attractive rate of return is larger. And this time is 10%. We want to know if we require a minimum attractive rate of return of 10%, if this is a good project. So what we're going to do, we're going to use the same equation for payback period. This time we're going to use for 5%. So I'm going to give you my first guess, because normally if the minimum attractive rate of return go higher, the payback period is going to get larger. So that's why I'm going to start my first guess 3 years. And then I'm going to substitute in my payback period equation. So you're going to have 1,050 for the first cost, plus 250 minus 75 times P given A, this time 10% and 3 period, plus the salvage value, 600 P given F, 10% and 3 period. Now I'm going to get the number. After substituting P given F, P given A from the table, you will get negative $59.23. Now my next guess, so actually this should be n prime, should be equal to 4 years. Same equation, I'm going to change n prime to 4. So it's going to be 1,050 plus 250 minus 75 times P given A, 10% and 4 period, plus 600 P given F, 10% and 4 period. If you do so, you're going to get positive $111.53. Obviously, my payback period is somewhere between 3 and 4 years. So I'm going to show you the n prime 3 years. I get the net value of negative $59.23. For n prime equal 4 years, we get positive 111.53 here. So what we're going to do, we're going to do a linear interpolation. You're trying to solve for n prime here. If you do so, the n prime you're going to be equal to 3.4 years. So obviously, this is also much less than 7 years, which is the useful life of the equipment. So it means you're going to recover your initial cost somewhere around 3.4 years. So it means this is an acceptable project, even with 5%, with 10%. It means the higher rate of return, the higher payback period you're going to get here. For example, if I go this one 20%, then prime is going to be even larger. So for 5 and 10%, definitely this project is acceptable.